Okay, let's try this again. Let me start. Okay, things look snappier now. I basically just restarted a bunch of apps. I don't really know what was going on, but the Xorg process was at like 70% CPU when I wasn't doing anything. So, okay, now we have failed the make map test, which we shouldn't really. So let's open make map test. Right. Oh, so let's go make map.c, I guess. And we're going to say goes, we'll do init omg config. Right, now we have free kanji keys output problem. Free kanji keys. All right. Now we need to do the same thing here. Okay, everything passed. Let's clean and just try one more time. Okay, good. So, okay, we want to make a fix-up for this right here. Right. Now we're going to go to kind of stats and rebase everything onto what we just did. Git rebase onto fix flags. Oh, there's no S. Okay. Oh, that worked. So now its tests are probably not going to pass, I'm guessing. Let me collapse the fix up commit. The fix flag, get rid of fix flag. Okay. Now let's look at commit 4 and see if it looks a little bit better. So we have default mapping, that's that. Okay. So really, if I were sharing this with a lot of people, and I know people were looking carefully at this code history and reviewing it like over email or something, or reviewing the code somehow, I would clean up this commit and split it up. But I don't really feel like there's a big, I don't have a big motivation to do that at the moment. So I'm just right now. I'm just looking for stray like extra blank lines that I've added because I didn't. Maybe because I didn't. I didn't like make a clean fix up. Anything that's very simple to kind of clean up, I'll clean up now. But what I can see right here is that it seems like the commit really does only do what I intended it to do, more or less. So mapping include kanjis. Okay. Okay, good. So, so let's see. What else did I want to do? I'm gonna look at my notes right now. I think okay. I wanted to add a hiragana to katakana command. Oh, there's actually another thing. So git grep, something simpler. Key index type. So this thing, I'm using the wrong naming convention. So let's fix that. Let's go to let's let's just fix that. There's also a function that should return it, but instead returns int or something like that. So romaji.h car to key index. All right, this should be called key index. All right, key index. Okay, so then we go romaji.c and look for, oh no, we look, yeah, we look for this. We want to call it static key index or die key index. Okay, so there's something weird about this, which I have reservations about, but I'm going to go ahead and do it anyway. The thing is, there's no real reason to use a smaller type here than an int, and so I would imagine you want to use smaller types if you're packing these into like a data structure, or you're storing it several times and you don't want to use up extra space. So really this ought to just be an int, I suppose. But then why do you even use a type def at all? Because it kind of seems like this is just obfuscating what is actually happening. And so, in other words, you don't really know what a key index is. Like, it kind of sounds like it might be a struct. Actually, it doesn't sound like that, but it could be. If you hide a type def, it could be a struct or something. And so, whether or not this is helping readability or making, or like actually, or whether or not it's helping or hurting, I don't really know. And so I'm tempted to just make this into it, just hard code it as an int. In fact, because it's not really stored in any like structs or packed into arrays, I don't really see a point in using this at all. So and even the Linux kernel coding style kind of discourages type defs as far as I understand, or maybe it bans them completely uh, because it does kind of obfuscate what's actually happening. And really, like, key index is kind of obvious that it should be a small number, and so int is fine. So yeah, I'm not sure how I want to handle this. Maybe I think that I just want to make it an int. So we use typedefs here for strings of certain length, which makes sense because you don't want to have to reconsider what the length ought to be every time you type it. But here, but for this function, I don't really see what the point is. Char to key index. Char to key index, I think, does not really make sense as a size t either. Int really ought to just be a int index. Okay. First key offset. Times equals mappable char count. Now I'm okay with casting it to a size t here because we're multiplying it by larger numbers. So that's okay, I suppose. Oh wait, did I actually use key index t in an array somewhere? No, I don't think so. I have to use it in keyboard.c, I guess. Key index t. Index t non-shifted. So here it kind of makes sense a bit more. Like I can kind of see why it helps to have it to say what the type is right here. So the type kind of helps indicate that this is a key index, non-shifted key index, key index. Int. Okay. Anyway, let's go ahead and use ints where keyboard slice, ki to slice. We'll call ki. I don't like the super abbreviated variable names here that much. In fact, we do use abbreviated variable names quite a lot for this exact purpose. So maybe I do want to actually go through with using this type def. So because I don't want to change a whole lot, I kind of want to keep things as they are without making things very different. Char to key index or die. So why is this a size t? That doesn't. Yeah. Okay. Great. So now we can get grep key index type, which should be just keyboard.c. All right. Great. So I'm going to do find and replace key index type with key index. All right. Oops. Apparently I. Okay. Shifted key index. Okay, we don't need this anymore. that again. Keyboard.c should be a simpler change now because we're just changing the name of a type def. Okay. Right, but we do have to change it to omaji.c because we are using it in a strange char to key index or die. Or we'll just do that. Car. And here we can do key index, char to key index. Okay, we do actually use it in an array here. That's what I thought. Key index. There we go. Okay. Fine. Fine. Okay. Kana stats. Oh, okay. We have to fix these other commits, don't we? Okay, so let's say fix type def name and use it more. Okay, now we'll rebase it. I'm not sure what just happened. I guess that that is like an that just does nothing. I forgot to pass -i. So I'm guessing that's not doing anything. FC6. It looks like it's doing something because it's changing the hashes of the commits. FC, yeah, it is. Okay, I guess it doesn't really matter. So we're gonna put this up here because it's very simple. We'll probably push that next. And I can do a make clean, make, yeah, that works. Okay, now if I do 4, this should also work. Okay, now 3 is probably not going to work because we're using that default init thing. No, I guess not. That's fine too. Okay, make this. This also works. Okay, so then we want to check out each kana stats. Make. Okay, kana stats. Kana stats needs to be fixed. Right. So we'll say init romaji config for CLI flags. Okay. But this has to be initialized to 0 as well. Okay, great. So the other thing I want to do is to add a hiragana to katakana command, which I could use for something in particular. Last strength. Okay, so I'm checking off what I already did in my notes. So now, so the next thing I would like to do, I think we can do it right before this commit. What is this in? What is in this commit? Name only. Expected test. Free kanji keys. Input test. Keyboard test. Oh no! In this, we only add kana stats. Okay, so this I'm just going to make the commit on top of this one, then rebase it later. Oh, but actually that's kind of going to be messy, I guess, because this also changes main.c. So let's check out to, and we'll say h2k command. Okay. Right, so let's open the make file. We're going to add a new command. Shared objects, h2k, h2k.o, and headers. Do we need a header for this? I guess no. Oh, you know what? Actually, I forgot I want to do is I want to I do want to add some documentation for the romaji thing here, I guess. Well, I don't know. Let's do that some other time because I'm not sure exactly how to do it. H2k char const v All right. Now we're going to open h2k.c, which is a new file, and we're going to include commands.h, right? And we'll go to, oh, we also have to open up main.c, and sort h2k, right? Okay. Then we also have to check for it here. And why am I doing this, by the way? So the reason why is because in nomaji.c, we have these things, which I'm going to change into, take them out of this. So this is a romaji kind of entry, which says, don't use hiragana version of it, but do use katakana version of it. So what I'm going to do is I'm going to change these to just have the katakana hard-coded here. And then I'm going to go down here and add calls to append mapping to add them. So in order to convert these from hiragana to katakana, I would like to just use my own code. There might be a website I can use to do that, but because I suspect I'm going to need to do this again later, and I would rather have a command line application to do it, I'm going to implement it now. And this is going to be a bit of a break from the kanastats command, which I've been procrastinating on anyway. So I'm just procrastinating a little bit more now. Okay, so we have this int h2k command. Let's go back to commands.h. Okay, so right now we're going to have to parse this. So we say if argc, we'll just make this an error. What do we want to say? Say no arguments allowed. Okay. And util.c. I think I have like an xf put s or something. Yes. Xf put s. Arguments allowed. And I guess that does not include the new line. F, and then we'll just do return 1. Oh, I have been using random number generators to give error, to create error codes. Let's do that again. So we'll do min max 92. Okay, and then yeah, so we're going to go ahead and okay, so I actually wrote the code on paper already. And we are going to need right. So one thing we're going to need is we're going to use a write function, which we have. We're going to have an xf write here. So void xf write, and we'll have void star and size t size, and then a stream to write it to, and we'll use the same argument order, pointer size, and stream. So I don't see myself using this, having the size and the number of members in two separate arguments. The reason for that is this is supposed to die if it does not succeed in writing any bytes. So we're not interested in partial results, and so in that case, we're just going to say write everything or just give up. And file. Okay. So we have xf write, and we have util.c. We're going to implement that. Where is xf put s? And the reason I'm doing this will be apparent in hopefully 20 minutes or so. And so we'll say if not f write, and wait, buff size and stream. And we actually are using something like this in keyboard.c, which now we're going to inline. right keyboard, no, buff, and then size and 1, and then stream. And here we will do die. And we guess, what do we do? We say what the error number is, which I guess is 1. F right error no. So it might set the error number. Man f put s. For some reason, we believe f get s would set the error number. But let's try this. F get s. Error no. There's no mention of the error number in here. So what we can do is in die. So we have how do we implement that? util.c. See, what I'm thinking is we'll set the error number to 0, and if it's not 0 here, then we'll output it. Show error no. If show error no, and error no. All right, so error no 0. Okay, die 1. And we can say f right failed. All right, that's it. Great. There's an error now. Okay. Then, oh, why is all this white now? What happened? Okay. So, great. Now, we also need to expose some other function. What was it? xf get one. There was kana range in kana stats. So let's open kana stats.c. Oh, never mind. So let's cat file h1 kana stats.c. I guess we can get it. No, cat file f. What was it? It was pretty print p. Cat file object name. We want to do it in source directory. Okay, good. So we're gonna have to use this in order to know in order to know what whether or not we're going to convert some character from hiragana to katakana. So I'm going to pull this out into a separate place. So we're going to go ahead and go into util. Let's make a new file. We'll call it like chars, I guess. This is very similar to romaji, but not exactly. So we'll take this. Do not support. Okay. Then we will call this function right here, and yank this, and we'll open chars.c, and we'll paste it here. We don't need any includes. We do need an include guard if not defined. Chars h. And then what is our style for these include guards? Oh, we don't even use them in all the places. Chars.h. Well, let's just start using it. Git grep. Looks like we don't use any extra underscores on the left or right. Okay, define chars h. And okay. Great. So do that. And so this h and stir cmp is in string.h, I guess. All right. And we're going to add this to the make file. We need chars. Oh, and do we have a list of header files? Yes. This chars.h. Okay. Code point range. And okay. So now, now what? So now we need to, we have that. We have this new function we need. So we're going to open h2k.c. And we can include, we do need that. We also need util for that xf write thing at least. Probably going to need some more, but for now I know that we need those. And so we're going to read everything into a buffer. So UTF-8 can have up to 4 bytes in it in a code point. And so in order to include that plus a null terminator, oh, we probably don't need the null terminator, do we? I think we don't need the null terminator, actually. Let's just call this 4, right? So we initialize that to 0, right? And we have the size of buff, and we're going to go into loop and read everything from standard in. So we're going to say int c, we're going to grab a character xf get c, read from in. And this, then we check if c is not equal to 1. That means we have not hit the end of the file. So we're going to go ahead and say c not equal to 1. Then buff size plus plus equals c. Okay. Right. So I'm wondering now when we check, we're going to have to check for c if being equal to -1 later on again. And if it is, then we do something different. Oh, I just remembered something. We did not change keyboard.c as xf right. Here, keyboard right. Oh, we don't use keyboard right. Bytes xf right. Okay. Right and size. That's fine. Okay. Anyway, where do we want to go back to? So here, so I was also thinking we do need to write a test for this. So we'll have like a test. Test is in H2K test. Okay. H2K test.c. Round include H2K commands.h, right? It's main void. Include test util. So we're going to do a start test. And how does that work? We add the file and then the name. How about empty? And we'll call h2k 00. And then we will go ahead and we'll do xf print out exit code send. Okay. Oh, so how do we actually give it an input file? I forget how we do that. We test util.h start test store in temp file const string. I guess we need to use store in temp file. Git grep in equals. Where do we change in? We change it in here, xf open input test. Huh, so we'd actually do something very simple, I guess, because we're redirecting input from a separate file, and I want to make sure I do it consistently in all the test cases. So we do a start test, store in temp file, and then we open it, and then we restore it to what it was before. Okay, that's fine with me, I guess. So say input file, input file. So we're probably going to have, now we're probably going to make this into a parameterized test kind of thing. So static struct test cases equals, and we'll call it char const in, char const out. Right, so we'll do, I guess we need a name, char const name, empty. All right. So then we're going to do int I for I 0, I is less than test, or we want to call it test I if we want to make it consistent. Test I, test cases, size of test cases divided by size of test cases item, test I plus plus. All right. Okay, great. Mapping dot kanji. So then we start the test. We store in temp file in name. Okay. Store test, store in temp file. And here, exit code. Or here we can do this int exit code, I guess. Wait, how? I think exit code is always going to be 0. Let's just assume we don't need that exit code thing, and we will compare it to 0 explicitly. So store in temp file, and then we're going to open the file, and then we're going to run h2k 0, 0. If h2k int exit code, exit code equals that, and then if exit code, then we'll print out an error, except printf out non-zero exit code. Okay. Right. So now we can close the we can close it here actually. Xf close in. Oh, I think I have a. Did I have a way to close and set to null as well? Xf close here. Do in equals standard in. Okay. So we store in temp file. We open that temp file. Store the input there. Let's start the test down here. We don't have to start the test before we actually do anything. Then we have the end test. End test, expected content in file. No, end test here. End test. Then we do test cases, test I dot out. Okay. Exit code, close. Should we close it after we end the test? Maybe we should do it after we end the test, like here. That feels a little more cleaner. Okay. Exit code. Input file. Okay, okay, that's looking better. So now let's open h2k.c, and we're going to, so let's see here. How do we want to actually make this work? So we're going to do xf get c if c is not equal to -1. So let's get the test building first, right? So let's just say, let's just ignore this. We do need int c. Okay. If if c is -1, then break. So then we got to do out. How about xf put c? Was it? Edit util.h. xf put c. Yes, character, and then out. Okay, so this is just catting the file basically. And here we return 0. And now we can try h2k test. That should work. Keyboard bytes, xf right. Where's keyboard.c? All right. Util.h, xf right. So let's see. Okay, that's fixed. Then h2k.c. All right. Let's not use those yet. Okay. H2K test, xf open. H2K test, okay. We need to include util.h. Okay, let's try again. And h2k test.c. We don't have the terminating thing here. Return 0. Okay. Now make. Okay. Bug at there. Test is already executing. Okay. End test, start test. Start test, end test. Why it's telling me a test is already running. So it's telling me a test is already running. We start the test. HK test, test util 79. Oh, it's starting a test up here, which you don't want to do. Let's try again. Okay, good. So we also want to handle, how about like non-kana, right? ABC should be ABC, and let's use capital letters too. ABC. All right, just to make sure the tests are actually, test infrastructure is actually working. Okay, good. It does fail if I add in an obviously wrong test. Okay, so now we're going to add, let's call one kana, one hiragana. Okay, and we'll just say like this small a, small a, which is the very first hiragana. We'll call it that converts to that. Okay, so we yes. So if it's not equal to 1, so we're gonna have to use this buffer now. And once the buffer gets to be full, then we're going to actually convert the character. So if c is -1, then we break. Otherwise, we put the character, and then we would say xf, let's see, buff size plus equals c. Then if size equals 3, then let's do the conversion. Hiragana to katakana, buff. All right. Now that should work. Okay. Where is hiragana katakana defined? Romaji.h hiragana katakana. Okay, here. But I don't think that's where it belongs. I don't think that should be there. Oh, but I've already pushed the commit which publishes it to GitHub. So let's just keep it there. Because really this hiragana katakana function should be in chars.h, but it's not. Anyway. Okay. Stack smashing detected in non-kana. What happened? Size. Oh, we have to set size to 0 here. Okay. No new line, no new line. Okay, so we're not actually converting it somehow. Edit romaji.c. Okay. Now convert 2 bytes, convert 2. Okay, I don't see why that would not work. Edit H2K test. So what is the actual output? Actual output is... Okay, yes, it's not converting it for some reason. Okay. Size is 3. Size is this. Oh, I don't see. Oh, because I didn't actually write it out. Oh, because I didn't write it out at the right time. So we're going to do xf put s buff. Oh no, xf right. Buff size 3 to out. All right, let's try this again. If non-kana. Okay, so now we're not getting the complete. We're not. This is not working anymore. So ABC, AC. Okay. Right. So we need to drop things if it's like if it's. So if size 3. So we need to decide if it's if size is 0 or no, if C and 80, then we're done already. So we're going to do xf right, buff size out, and then size is 0. Let's see if that works. So I kind of know what the code is going to look like, but I'm just doing test-driven development now, kind of for fun, and also to make sure the tests are complete. Okay, so now we let's say if it's not if we get one of those characters that's a, so yes, now if we get an ASCII character, we just drop it out and we print everything out we've gotten so far. Now if size is 3, we call hiragana katakana. So this can break if I have 3 characters which are non-ASCII and are not hiragana to katakana. So let's try this. So we'll do non-kana non-ASCII. Okay. So let's do like what? We'll pick a kanji. Okay. This is definitely not going to work. Make H2K test. Okay. Good. So the reason this is not working is because it's not in range. So we want to say if If kana, what's that function called? Cars.h. If code point range buff is equal to code point range hiragana, then we'll do this. Okay. Now it should pass. Good. Okay. Edit chars dot. Let's see. We're going to go back to our test file. This is looking better. So as soon as we have a non-ASCII character followed by a kana character, as soon as we have an ASCII character, we're going to dump everything into the buffer, right? Um, so that's good. Now, what happens if we have like if we have a 2-byte UTF-8 code point, and then we have right after that a hiragana that we need to convert. Now that's not going to work because we don't actually handle it. We have because we wait till the size gets to 3 before we clear the buffer. So let's say 2-byte UTF-8 char. And what are we going to use for that? I guess we can use something like an accented A or whatever. Let's see here. Let's look for the word naive. Naive has an accent on it. Naive. Naive. Here we go. Okay. And right after it, oh, now I'm laggy because has so much crap on the page. Okay. Good. Now we're going to give it a that. Okay. That's not going to work. Good. Okay. So the idea is that I guess we need to figure out that our buffer is full, even though it's not really. So we need to handle size is 3 and UTF-8 byte. The UTF-8 code point is 3 bytes long, and also size is 2. So if size is 3 or size equals 2 and buff 0. Okay, what's the numbers I figured out to do this before? Size is 2. If let's see. Now, if it's 2 bytes, the first byte is going to have 110 in the front, and so that means we have to do a bit. We have to compare it against the bit mask 1110, 0000 in the first byte, and so that is E0. So E0. So we compare it to E0, and we check if that's equal to C0. And E0, C0 equals. Okay. Now that should work. Stage 1. Okay, good. Great. So now I guess we want to check for a 4-byte kanji. So let's say let's make this more interesting too. We don't have that many accents. So I know pinyin has a lot of accent marks. So here we go. Let's try A. Bang. A. Okay, so that's 4 bytes, and we'll try ga and ga. Okay. So it should not convert these two. And all right, so we can check diff. Okay. And that did not work for some reason. What is the difference? I don't see any difference. Expected. Let's do a hex dump -c and a hex dump -c of this. Okay. Oh, I see the second one has a lot more characters in it. Test out has a lot more characters in it than the first one. E3, E6, E3, A0. Okay. So at this byte, which is the 8th byte, we start to see something different between the expected and the actual. The 8th byte is 1, 2, 1, 2, 3. That's 5, 6, 7. So at this point, it gets to be different, I guess. What's going on here? Oh, you know what? Maybe it's because we're writing 3 bytes here. Okay, I'm confused. So why did that work before? Because we shouldn't be writing exactly 3 bytes. By 2 kana. Okay. Okay, let's try this again. Okay, H2 katakana. 2 kana. Okay. So why is the first one working when I write with 3 bytes here? That doesn't make any sense. Oh, because I'm dropping null bytes, aren't I? The test case infrastructure drops null bytes automatically. I don't want to do that. Edit test util.c. Okay. This is not something you want to do here. It's not correct at all. So we'll do, let's see here. Test output pipe read. So we don't want that to happen. Start output processor. Test output pipe read. Start test pipe. Okay. Start test. Like int flags, I guess. This is going to be a complicated one. Complicated test. Or complicated commit, rather. But actually, it's not that complicated yet. Maybe it's okay. So I'll have like int flags here. But int So I basically wanted to not do this stupid test output pipe read. Start test. Fine, test util.h, I guess. We can do like void config tests. Int flags. Pound define. Ignore tests. Config tests. Ignore null bytes. 1. Okay. Edit test util.c. Okay, we don't have a config test function, so let's go to start test. And we'll do int config tests, int flags. All right, so right. Int flags. int flags. Yeah, how do I want to do this? So maybe we should use a struct here. The struct is not going to end up. Struct is going to be nothing though for now. So let's do static int flags, and we'll say ignore config test. So flags equals flags. And do we want to set the default to ignore the null bytes or not ignore the null bytes? I rather think we want to have the default be to the default should not ignore them. So let's go to start output processor. We can say if b or not ignore bytes, not config test ignore bytes. Let's see, flags and config test ignore null bytes. Okay. Config test. Okay. Config tests has to have void return. Alright, now we're going to have some keyboard tests fail. So edit keyboard test. We'll say config tests ignore null bytes. Oops. Okay, it saved it. I didn't mean to close it, but it did save it. So input test. Edit input test. Void. Okay. Let's try that. Now, okay, we're back to failing these tests here, so that's good. So now we're back in what we actually want to work on. So we have diff. Now they're binary files. Okay. So, right. Okay, h2k.c. Edit h2k.test.c. Now, so what we really want to do here is use the size as the amount of bytes we want to write. Okay, now the tests are passing again. Now we'll have 4-byte UTF-8 char and for UTF-8 char and to kana, I guess. Now I know a certain character we can use for that. I think it's here. There's a kanji character which has that many bytes in it. What about this? This looks like it might be unusual enough to have 3 bytes. So echo, let's see, 3 bytes. Okay, no. Oh, it's DMF. Okay, this should be 4 bytes long, if I'm not mistaken. Yes, okay. But we do need another character there that's 4 bytes long. How are we going to find that? Let's put that there first. Let's find another kanji character. I think I can recall one that was like this. Yes. Yes, it was either this or this, I think. Oh, did I just type the same one twice? C-A, there. Okay, let's see. Echo dash N. Okay, 6. No, they're both 3 bytes each. Okay. Oh, you know what I can use? I can look at this. This has a browse. My other input method has a browse feature. Okay, and so here are a lot of characters that have 4 bytes in them, or should. These are sorted last. So let's just pick one. Yeah. Use that. Then if we go to echo or 4. Okay, good. I guess we can change these kana to something slightly different, like wa. There. Okay, that looks correct. So now if we have a failure. Okay, good. Okay, so now we need to check to see if the size is 3. Oh, but we're stopping at 3 always, so we don't want to do that. So we can make a function which checks if it's a complete character. Int complete UTF-8 char const buff. And if we need the size as well, don't we? Let's do static comma int size. If size equals to, oh, we already have that. Size equals 2, then we return true. So I'm going to put several return trues because I don't like wrapping if statements if I can avoid it. And 0 by, okay, it's 3. So size is 3. That would be, we can AND it with F0 and compare that to E0 for size 3. F0 equals 0. Wait, is that right? We compare it with E0 sizes. E0 F0, E0 C0, 0 F0. Yeah. All right, we do E here and F here. Return true. Okay, complete UTF-8. 8. Otherwise, actually, we do want to say return this. Okay. Right. Otherwise, we say it must be 4, so we're going to just say true. 1. So if complete UTF-8 buff size, okay, free, return true. Oh, we don't have a true constant. 1. Okay. Failed to write for some reason. Why would it fail to write? I do not know. 83. Non-kana. Failing to write non-kana. Could it have something to do with not clearing the buffer? Oh, maybe that's why. I think that we need to clear this buffer. I think that I'm correcting memory because this hiragana to katakana is going to continue until it sees a null byte. So let's say buff. Let's try that again. Nope, still not working. What is going on? Why would it fail to do an F right? Because of the change we just made. That is strange. F right. Util.c. And we are showing standard error if it's there, right? So not sure what could be wrong. Let's see. Let's look at die. I mean, we should be showing the error number. Print error, otherwise print. Okay. F right. At util dot. Then we print out. F right. Okay. Well, why would it fail now that I've actually made the code better? Size is 2, otherwise. Okay, so if size is 1, it's going to return true, which doesn't make sense. So if size is 1, then we return not 0 and a. Okay. Size 0. Okay. Break. Let's try that. Okay, good. Now, I guess this is fine now. I think that using the test-driven development actually made the code a lot simpler than what I had in my notes. But I'm not sure if this is all exactly if this is too simple. Maybe this is too simple, and there's a bug that I'm not thinking about. So I guess what I'll do is let's try it out in omaji.c. Let's do so. We're going to go ahead and do /new sort h2k. That works. Okay. And we're going to take the romaji.c file. Yes. Okay, good. Looks like that's working. Yeah. Okay, I'm just comparing these to what the hiragana is on the left side, making sure that they're what I expect. And yeah, it looks totally correct. That's great. And it doesn't even look like there's any corruption or anything like that. Yeah, let's commit this. We can put it right before kind of stats. And well, let's see here. Am I forgetting something? Okay, let's commit it. HK command, and let's merge what we have. So I'll check out conastats, git rebase onto h2k command. Okay, good. So now I can do this. All the tests should still pass. Okay. Okay, command. Git branch delete h2. Good. Okay, so this command was an easy thing to just kind of blast out, and the way we did the test configuration is a little hacky, but I'm not sure if I really care enough. I mean, I think that's probably fine. The test output processor might change might like never get any more complicated, and then it's not going to make sense to start that thread when when we're not dropping null bytes. So yeah, we could simplify it now to never start the thread if we don't need it. But the thing is, this code is simpler if we start the thread anyway, and then do the flag check inside the thread. So I guess I'll just keep it as is. Okay. Yes. So H2K. All right. So this all looks good to me, and I do feel like we made some good progress. Uh, but yeah. This is the video for today. Next time, I believe that uh, I will be able to stop avoiding the kind of stats command. Actually, so stats.c. So this is fortunately now we no longer need this to be here. We can just include the char's header file there. Now we have the range function that we wanted. So, and we probably want to put complete UTF-8 in a header file. Now that I think about it, because that makes sense to store it there. And actually, maybe we even can. We're already doing this complete UTF-8 thing. I want to see if I have git grep. We might be doing it somewhere else. I wouldn't be surprised. Static void set UTF-8 byte. No, maybe not. Okay. Let's call this is complete UTF-8. UTF-8. All right. Oops. Why is that not okay? This here. Okay. Now I don't know if I'm going to want to put it in that shared file. Maybe because it kind of seems like we should be putting it in that shared file. But no, I was thinking that we would just treat them all as treat it as a byte stream, just not even care about the like UTF-8ness of the bytes at all. I don't think that it's necessary to check it. In other words, because we're comparing the bytes that were in the kind of stats command, we're going to be comparing the bytes that we read out of the input stream against like sequences of kana that might be 1 or 2 kana long. We don't need. That means that we don't. We we can just check for things in the map to see if they're complete or not. We don't need to do anything more fancy than that, I suppose. So I think that we won't need to share this function actually. And yeah, I don't know. I guess we don't really want to check for size equal to 0. Let's if like size is 0, then we say it's a bug. Bug. Size is 0, right? And if size is 4 or greater, we know this is completely UTF-8. So if size is greater than 4, then we can say bug. Size is too big. Okay. Maybe we can put it here. Do here. If size is 4, then we return 1. If it's otherwise, we say size is too big. Not size. Okay. There. Oh, but now it looks like a switch statement actually. So we can do switch size and case 0. 1, case 2, case 3, case 4, and default. And okay, that looks pretty, I guess. Then we can change this. Okay. Nah, I don't think I like that one. Okay. Now that's quite pretty. So anyway, so next commit we should be finishing the kind of stats command, because I can't think of any other thing to do before it that will make the commit simpler. So we are going to make the kind of stats command simpler because we just exposed the code point range function to make it public, and so we're going to be able to use that without writing it again in kind of stats. So as you can see, this file over here is on the left side. Kind of stats.c is quite simple, and the rest is just the actual algorithm. The real core of it is just what has to be written. So anyway, thank you for watching.